Welcome back. I'm Muggsy, and today I'm going to explain ionic bonding with polyatomic ions. Before you learn about ionic bonding with polyatomic ions, you should first know about polyatomic ions and about ionic bonding. I've got videos on both, so go check them out now if you're not comfortable with those things. For instance, you should be able to bond nitrogen with sodium to make sodium nitride. 3 sodiums and 1 nitrogen. You should also know some of the basic polyatomic ions. I ask my students to just memorize 6 of them. Your teacher might ask you to do more or none at all. It's up to your particular chemistry class. Okay, so what if I asked you what happened when you bond carbonate and sodium? Well, the first thing you would need to know are what are the charges of those ions. So carbonate is one of the ones I asked my students to memorize. They would know that it's CO3 with a -2 charge. This is a polyatomic ion because that -2 charge doesn't belong to the oxygen and it doesn't belong to the carbon. It belongs to the whole thing, the whole complex of 1 carbon and 3 oxygens. Poly meaning more than one, atomic meaning atoms, and ion meaning it has a charge. Okay, and you should also be able to tell me the charge of a sodium ion. You should be able to look in column 1 of the periodic table, see that sodium has 1 valence electron, so it would lose that 1 valence electron to gain a +1 charge when it forms an ion. Okay, now that we've identified our 2 ions, we've got our polyatomic ion carbonate, which is our anion, our negatively charged ion, and our sodium ion, which is our cation, our positively charged ion. Now we just need to balance these 2 charges. Well, the lowest common product of 2 and 1 is just 2. So in order to get +2 here and -2 here, I'm going to need 1 of these, and I'm going to need 2 of these, right? Because 2 sodiums will give me a positive charge of +2. 1 carbonate already has a charge of -2, so I don't need to do anything to that. +2, -2 cancel out and leave us nothing at all. So this is going to be balanced. When we're writing the chemical formula, what goes first? If you said the sodium, you're correct, because our cations always go first. Then we put our anion, carbonate, CO3. And then we write in any subscripts to tell us the numbers of them that we have. So we only have 1 carbonate, so we don't need any subscript here. And we have 2 sodium, so we put a little 2 after that sodium. Na2CO3. And we would call this sodium carbonate. Here we have calcium and we have hydroxide. Hydroxide, again, is one of the polyatomic ions that I ask my students to memorize. And so they should know that it has a -1 charge. Calcium is in column 2 of the periodic table, so it's got a +2 charge, or 2+. Okay. If these 2 were to come together in an ionic bond, which they would, because a positively charged thing and a negatively charged thing like to come together to neutralize, those opposite charges attract, just like a magnet, right? Well, we would need to balance these charges, right? So the lowest common product of 2 and 1, again, is 2. So in order to get 2 here, we just need 1 calcium, and in order to get 2 hydroxides, we would need 2 OHs. Now again, we don't want to put something like this, because that's not telling me 2 OHs, that's telling me 1 O and 2 H's. Same thing if we put the 2 here, that's not 2 OHs, that's 2 oxygens and 1 H. So in this case, if we want to tell our reader that we have 2 OHs, we surround the whole thing in parentheses and then put a little 2 outside the parentheses. That's telling us we have 2 hydroxides. Okay, now we write it all together. The cation goes first. In this case, it's calcium. We put any relevant subscripts. We only have 1 calcium, so we don't need any subscripts. The anion goes second, and in this case, it's that OH. So we're going to put the OH, and I think I'm going to make a mistake. We'll put a little 2 after it because we have 2 OHs. Oops, I screwed up. Again, I'm not telling you that I have 2 hydroxides. I'm telling you that I have 1 calcium, 1 oxygen, and 2 hydrogens. That's not correct. That's not what we have. We have 2 hydroxides. So we have to put the whole thing in parentheses, hydroxide, and put the little 2 after it, telling us calcium hydroxide. 1 calcium and 2 hydroxides bonded together. Calcium's got a +2 charge. Each of those hydroxides have a -1 charge, and there's 2 of them. So +2, -2, they cancel out and form a stable ionic compound, calcium hydroxide. Okay, let's keep practicing these examples. Okay, what if I want to bond a sulfate ion and an ammonium ion together? Well, again, these are ones that I ask my students to memorize. They would have to remember that a sulfate ion is SO4 and it has a -2 charge. And an ammonium ion is the only polyatomic cation. It's NH4 with a +1 charge. All of the other polyatomic ions are anions like sulfate, phosphate, carbonate, nitrate, etc. Okay, again, we just balance the charges. So sulfate has a -2 charge, ammonium has a +1 charge, so we're going to need 2 ammoniums, 2 of these whole things, to balance out that -2 charge. Okay, and I feel like I might be making a mistake here, but let's just write this down. We've got our sulfate, SO4, and we've got our NH4. Okay, I made a lot of mistakes here. The first thing, and kind of the most obvious mistake, is remember when we're writing down the chemical formula for a polyatomic ion, what goes first? If you said the cation, you're right. And this sulfate isn't the cation, it's the anion. It's negatively charged. Positively charged thing always goes first. So let's cancel this out and write it with the NH4 first. Okay, we'll put that 2 in front. And then we put the sulfate second. Okay, it's right now, right? Actually, no, I still screwed up. Remember, a 2 coefficient in front of a chemical formula is telling you the number of overall molecules. So this 2 is telling me that I have 2 NH4 SO4s. And that's not correct. I don't have 2 NH4 SO4s. I have 1 SO4 and 2 NH4s. So in order to show that, remember the 2 goes as a subscript after the parentheses. So what this is saying, this is now correct. I have 2 ammoniums and 1 sulfate. The charges balance out because 2 plus 1s balance out 1 minus 2, and we have a stable ionic compound. The cation has gone first and the anion is second. A lot of students also kind of want to write the charges here. There's a +1 for that ammonium and a 2 minus for that sulfate. That's actually incorrect to do when writing out your final chemical formula. It's totally fine to do that when you're actually figuring out what the final chemical formula is going to be. But when it comes time to write this down, like if I had a bottle of ammonium sulfate, I wouldn't write those charges in. I would just write NH4, all in parentheses, 2 SO4. Okay, let's try an even more difficult example. In this example, we want to see what ionic compound forms from iron 2 and phosphate. Again, phosphate's one of the ones I ask my students to memorize, and it's the one with the biggest charge. Phosphate has a -3 charge. Now, what is the charge on this iron 2? If I look at iron in the periodic table, it's somewhere in the middle. It's in that transition metal area. And the problem with those transition metals is you can't really predict exactly how many electrons they're going to have like you can with the elements on the wings of the periodic table in columns 1, 2, and then 13, 14, 15, 16, 17, and 18. But fortunately, I've told you with my formula exactly how many valence electrons this iron has. It has 2. For transition metals, we write the oxidation state, you'll recall, in parentheses in Roman numerals after the atomic symbol, because they're different versions of iron. Some irons have 3 valence electrons. Some might even have 4. And we're going to ignore those because for this particular problem, we know that we're working with iron 2, the 2's in Roman numerals, and so it has 2 valence electrons, so it's going to lose those 2 valence electrons to become stable and gain a charge of +2. Okay, so phosphate's negatively charged, iron 2 is positively charged, so they're going to come together, they're going to attract to form a stable ionic compound. The issue is the charges aren't equal. So if the +2 comes over and joins that -3, we'll still have a -1 charge. So again, we need to think of the lowest common product of 2 and 3, and that happens to be 6, right? So in order to get a charge of -6, we're going to need 2 of these phosphates. And in order to make this 6 plus 2, in order for that to become 6, we need to multiply it by 3. So we're going to put a little 3 there. Okay, then we're going to stick them together to make the chemical formula. Remember, the cation always goes first. In this case, that's the iron. So Fe. Be sure to include that oxidation state. That's useful information. And there's 3 iron atoms. And then we put our anion next. That's the PO4. And then I'm going to put a little 2 there, and we're done, right? Now, I made another mistake. Yeah, this actually looks like there's 1 phosphorus and 42 oxygens. That's clearly wrong, right? Remember, with all of our polyatomic ions, just like up here, we put the whole thing in parentheses, and then we put a little subscript after the parentheses to tell us we don't have 42 oxygens, we have 2 phosphates. So 2 phosphates and 3 irons come together to form iron phosphate. So this is the chemical formula of the compound that forms from phosphate and iron bonding together, iron 2. Okay, I think that really covers most examples that might come up when talking about bonding with polyatomic ions. It's really just the same as bonding normal ions. All you're going to do is balance the charges out so they equal 0 because a stable ionic compound has a charge of 0. The only difference is with polyatomic ions, instead of an individual atom like iron, we're talking about multiple atoms bonded together in one polyatomic ion, and we're just balancing those. So instead of balancing individual things here, we're balancing phosphate ions. Okay, you should practice this. I'm sure you're going to find it pretty easy if you already are comfortable with your polyatomic ions and ionic bonding. It's just a more advanced version of what you've already been doing. Okay, I'll see you next time. Thanks a lot.